have to start from task continuation. And in the laboratory, you don't have task continuation. You only have to create parallel processing with task parallel library, and you have to implement breaking of task, and you have to implement. You should implement some mechanism to inform user about a progress. Okay, let's go. Control F5. No, nothing happened again. I have some strange message then, but I forgot about to check it in the past. Then let's go in different manner. Okay, last time I showed you how you can wait for the result, how you can take a result in general from a task. We talk about it. Next, how you can wait for the result with the time, the specified time, or with a cancellation token. How you can wait for more than one task. One more information, the slide which is absent here. The slide which is absent. Oh, I don't have here. I don't have. It was in the previous presentation about method which is called wait any. I lost this. I lost this slide somewhere, or I forgot to create it. I don't remember. There will be the day when I will add the slide, but it won't be in this week, probably. Next, what I showed you was method when any and when all. When all and when any. I remind you that this method allows you to catch the tasks, the previous task to one task. And you can operate with this one task easier because you can send it to the different method, or you can wait. You can wait when each method will be finished, not only one method, but each method will be finished. Example, in the case when you need results from each method, not only from one, for first or something like this. And one more method was presented, when any, which gives you possibility to detect which method is finished first. It's very useful, I think, in case when you have to process something, you have possibility to do it in different manners, but depends on something. One method can be faster than other, and if you need fast result as fast as possible, then it's good option to run more than one process and take only the fastest one. Why not? It's possible. Example, I explain you that example, you would like to download something from the internet. In the internet, in different places, you have the same data, but sometimes one place works better, or one service works better, or in different times, second service works better. Then it's good to, it's possible to read data from both services, and depends on the fastest one you receive only. You take result only from one, the fastest. Of course, if you should do it in this manner, depends on the solution, depends on situation, and depends on needs. I didn't tell that you should do it always. You should run two tasks because maybe one will be faster. No. Only in the situation when you expect that one can be faster, but you don't know which one, and you need the result very as fast as possible. Because of course, if you would like to download data to show that to the user, if the user will wait, example, 1 second or 1.2 seconds, it isn't difference for the user because probably it isn't possible to observe by the user that it's difference between these two possibilities. But in the systems, real-time systems, the difference can be significant. The difference 0.2 seconds. Of course, everything depends. Everything depends on the situation, needs, on the process, or different types of different parameters of the situation, because application aren't finished on the, I don't know, web pages. Example, application can be created to many different, many sometimes strange cases. Example, you can make application to control some kind of machine. Example, I don't know. Example, CNC machines. Why not? It's possible to make application to control it. Of course, the process is controlled by the embedded software, but if you would like to cooperate with this kind of machine, you need a software on the computer, installed on the computer too, to communicate with the CNC drill or something. Okay, it was presented during the last lecture. Today we are going to explain how to continue the task, how to take result from one task, put it to the second task, and process it. Yes, I don't know how to say it. It's possible to continue the task with the results from the previous one. To do it, you can use three methods. First method is continue with, which is which you can use this method. You can run on the task which is defined. Second two methods is task factory continue when all, and task factory continue when any. During the previous presentation, I told you about when all and when any method. First method can be used in situation when you need to catch more than one task and wait for finishing of these tasks. Second method, when any, is used when you need the fastest one. Then you can discover, you can imagine that continue when all and continue when any works in similar manner. It means when all tasks are finished, the processing will be continue with next task, and the same situation with continue when any, the fastest one is finished, we will continue with new task which will consume the result from the previous one, the fastest one. Okay, let's go to the examples. Like almost always, I think that examples of code is very useful because you can analyze it, not only theory. That's something you can build in this or different manner, but examples of code allows you to analyze step by step what's going on in the solution. And more, you can rewrite it, example, in your own. If you would like to understand how it works, you can rewrite this code in your own manner and analyze what's going on, how it works. You can put some breakpoints, example, and check what is which part of code is executed when. Because as you know, the task is used to create part of code which will be executed in the different thread. Then you can the order of the process isn't certain in general. Okay, the example, like in the previous cases, we have print numbers method. It's useful because it's this method show us something on the screen and return something, or show us or both sometimes. Print something on the screen and return something. In this case, we have loop for which process some kind of logic. In our case, this method builds a string from the numbers and waits. Every iteration of our loop is waiting 100 milliseconds. It's when waiting 100 milliseconds. Then you can expect that 10 iteration gives you a latency about 1 second. And as a final result, it simulates, of course, this delay simulates a long-term process. It simulates process which takes longer time. As on the previous slide, I gave you an example that you would like to download something from the internet. And example, you can imagine that our process should connect to the internet and download something. The external server isn't as fast as you would like, then the delay exists, some kind of latency. Then this is a simulation. Of course, in the production code, isn't very often situation in which you should use this line of code, the delay. But sometimes it exists. Okay, and our method iterates as many as variable count is passed, as many times as variable count tells to our for loop, and as the result, methods returns builded string, builded from the numbers, yes, from the in numbers, as you can see here, as you can see here on the black part on the console result. Okay, and let's go to the right side. Let's go to the right side. On the right side, we have cancellation token and cancellation token source, which isn't useful in this case. In this case, they left after previous slides. If you remember, we had slide with presentation how you can break, how you can interrupt process in different tasks. Yes. Next line of code. I don't remember if I explained you that it's stopwatch, which allows you to measure time of code execution. In this case, we defined stopwatch. Stopwatch is started somewhere else in the code. You can stop stopwatch, and and to read the time which left from the start to the end. Yeah, it's useful sometimes, especially in the situation in which you would like to find optimal solution. You have to calculate something, and you have more than one method, or example, you have more than one method and you don't know which method will be the fastest, because you would like to use the fastest one. Then you can measure it. You can build one method, you can create first method, measure, create second method, measure, compare the results, and choose the better one. Then you can use stopwatch class to calculate the time, to measure the time of execution of code. Okay, and we had an example on the previous slide that code was execution almost 4 seconds, 3,700, almost 800 milliseconds. It means that it's almost 4 seconds. It was generated because we have delay. We have delays 300 milliseconds. We have delay 300 milliseconds for each iteration. If we will put 3 iterations, then we have delay 3 seconds. In current case, the delay was decreased, but it doesn't change a lot of, because you will see that execution time is very, very, very short in general. It's shorter than one delay. It's shorter one delay. It's evidence that our delay didn't work in our main thread, because our delay, our print numbers method was run in different thread with task factory. We run it in the different thread, because we have used task factory start new, method which created new task, and things described in the previous presentation were happened. But let's come back to our subject to method continue with, because I would like to explain you how you can continue the calculation with the result from the previous task. How you can continue with next task with the result from the previous task. Okay, I explain you what's going on here. Next line, console write line, start task execution is printed on the screen, as you can see here. Next, we configure our task. I will explain later what's going on here. Next line, end task execution, what you can see on the console. Next step, stopwatch. It means that it's the measurement of time is stopped. We print our code, print the execution time on the screen. Our code took from the stopwatch time which elapsed from the start to the end, from start to the stop. And it's printed on the screen. As you can see, everything from this line to this line took 54 milliseconds. It's in general very short time, especially because we have print numbers 10 iteration. As you remember, 10 iteration is equals something like 1 second of delay. 1 second of delay, but our code works only 54 milliseconds. It doesn't mean that we have results after 54 milliseconds. No, because our code should work more than 1 second. We only have defined, configured, run task after 54 milliseconds. And how it works. First part is generated with task factory start new. As you remember, task factory start new creates and start task. The method which will be processed is defined with the lambda expression. Lambdas is started here. It tells us that we have method without the parameters. And the next is arrow. Next, we have mustache brackets. Between mustache brackets, we have some kind of code. First element of code is in our code prints fetching data text on the screen, which is made after execution time. You can observe that first is execution time printed. Next, in the next line, we are waiting, our code is waiting for the result from our task, but the task started in the during this operation. Then the task was prepared, the memory was attached to our task, the computing power. It means that the core of a processor was attached to our task, and task started execution, his own execution. First line, as I told, is printing fetching data on the screen, what you can observe on the console. Next operation is execution of print numbers and the return result. As I explained, print numbers builds a string. Every iteration, we have 10 iterations. Every iteration, 10? Yes, 10, because it should be I should be lower than count. And I started from 0. And there will be 100 iteration from 0 to 9. I will be equal from 0 to 9. I will be append to our text in string builder class. I remember that I explained you what's going on with string builder class. It works like a concatenation of strings, but it's faster. It's faster than normal concatenation of strings, and builded string is returned from the print numbers. This result is returned because print numbers return as a result. It means numbers in string representation of numbers, and this result is returned outside of our task. Task is defined in this place. And on our task, we are creating second task, which will catch our second task will catch the result from the previous one. I mean that our task will catch the result from the previous one, and we can process something in the next task, in second one task with continue with method. If we use continue with method, we can create second task which will catch previous one. Sometimes I told you that the result is passed, but generally it's the task passed. As you can see, we have on our data, we have a result method. You remember that the result method, I will come back here. Oh, maybe one step back more. Yes, example here, that we can get a result from a task with a result property. If we use result property on a task, the result property will return us result, calculated result. And as you can see here, we have made the same situation in which we tried to take result from the data. Then you can discover that our data is equal a task. the previous task in general. Then I could use different name for this variable, for this parameter. But I wrote the data and it will stay in this, it will stay presented in this manner. And what happened? Next part of our task, receive a previous one task. This task took, the first one take some time, about 1 second. We know that it takes some time to execution, about 1 second, because we are passing 10 to our print numbers. Each iteration has delay about 100 milliseconds. Then print numbers should take in this situation something about 1 second. And our task is passed to the second task, to the second configured task. In this time, we can do something here in our code in the second task. Our second task, in our case, prints, gather the data, and to the string, we have added the result from the previous task. It means that our code is waiting on this line. Second task is waiting on this time to receive, as long as needed, to receive a result from the previous one. It's about 1 second, as I told you. And the last line is returns word OK. OK returns from the to the environment in general. In this case, our environment is defined here. It means that this result is assigned to the task variable. What's important, you have to understand that task factory start new produced a task. On this task, we have executed method continue with. This method returns for us task 2. This method produced second, we can say second next task, and this next task will be returned to the task variable. It means that we have catched in the task variable second task. We have catched second task, but of course it's connected with the first one. It's connected with the first one. Second task needs data from the first one. Then nothing is lost. Everything is catched, but we have reference in the task variable to the second task. It means that we don't receive a result from the print numbers when we will take a result from the task, but we will take result from this line, from this return, because we have anchor. We have anchor to the second one. You have to remember about it. And last line prints on the screen what you can see here. Prints on the console. OK word. OK is returned from the second part of our composed of our composition of task. Yes, I tell that it's composition because we have two tasks in which second task takes results or all tasks, not only results from the previous one we have created. First one, we pushed it as a parameter to the second one. Of course, it can be, you can think that it's complicated, but it isn't. In general, it's easy to create it without a continuation. Example, you can create one task and you can create second task with a parameter of type task, and it will be almost the same situation, but it's this kind of solution is more cute. It's better solution than two unrelated tasks. Why is better? Because, example, you can control some kind of process. I will show you on the next slides. Okay, let's go to the next example. The next example, it's the same situation with exception. With exception because we have two, we have three tasks and two continuations. Two continuations. First part is similar to the previous one, to the previous example, but in this case, I have added one more continuation. One more continuation. Sometimes this kind of syntax you can find that it's called sometimes in some kind of situation that it's called fluent syntax. Fluent, it means that you have task taken from the first tasks factory start new, and you can do something on this task. In our case, we can continue this task. Continue will return as task 2. It means that we can again continue and again and again and again as many times as we need, as many times as we need, because continue is, we can run continue method on the task, and continue method return us the task. Is something like a chain, something like a chain. You have you had in the previous year subject called design patterns. Design patterns, yes, design patterns, and there was chain pattern too. It's something like, you can say that it's something like this. Not exactly, but it works in similar manner. And as you can see on the screen, the result from our task processing, what is interesting, that execution time is shorter than in the previous one. In this situation, we had 54 milliseconds to from stopwatch start. We have printed start task execution, end task execution, and configured. We have configured task. In this case, in the second case, with 3 tasks with 2 continuation, we have shorter time. But this is, the difference is very, very small. Probably something on the computer, the system, operating system did something on the computer, and it was reason why in the previous one, why in the previous example, the execution time was longer than in the next one, because second slide has more code, more complicated code, because we have to create 3 tasks, not only one, and similar thing. But the beginning and the end is the same, then I don't have to explain you. You can see that start task execution, end task execution time on the screen. Start and end is printed here, execution is printed here, and our code is waiting for the result. What's happened inside our task? First task is created, is prepared. On the first task, we run a method continue with, which produce us second task. On the second task, we execute method continue with again, which create us third task, and third task is returned in and attached to the task variable. As you know, start new starts a task, then execution is started after creation without additional line of code. Our first part is prints fetching data on the screen, executes print numbers with a like in the previous example. From the print numbers, result is returned and passed to the next task. Again, I remind you that in general it isn't the string, the result, but it's task. It's the reason why we have to use the result property to take return value from the previous operation. Of course, it means probably you discover it, that there are 3 tasks in this case, and 3 tasks are executed parallelly. Second one doesn't wait for the previous one. Of course, he has to wait for the result. He has to wait for the result, but if we configure, if we add some kind of code before the line with data result, the code could be processed parallel with, example, print numbers method. I think that it should be clear for you. And our code is waiting. After first part is finished, our code prints gathered data and value from result. What you can see here, gathered data, and our code returns word OK. The return value is passed to the next next part of our task, third task. But again, I remind you that it isn't the return value, but it's the task, whole task. It's the answer why we take value from data from the property result. Like in the previous example, it's the same because we can do it as many times as needed. And we have printed gathered data 2 on the screen. Next element returns, next line of code returns as again OK. This OK is returned to the task result and printed. It's printed on the screen. You can think how happened. I'm thinking that we have line space, empty line here. It's taken from here, and I'm thinking because it should be 2. It should be 2 right lines. I'm thinking, but I don't remember. Let's see here. We have after numbers, we have 1 append line. Well, append line, it means that character new line is added to the end of a string. And I don't know, maybe it's the presented screenshot is taken from some kind of different code. Different, it means that it was added, example, new line here, or character or something like this. And escape. Oh, I see here. I found it. Execution time. The execution time has new line here. It's the reason why we have new line before execution time, and maybe something was similar situation in the second one. Oh, I know, because gathered data, as you can see, gathered data is printed with a right line. Right line adds on the end new line character, but data taken from print numbers has new line 2 with append line method, added with append line. It means that we have 2 times new line in this string, printed in this string, because one new line exists inside the result, second one is added by right line method. Then it's the reason why we have the empty line in the results. It's interesting sometimes to analyze and remind how it's possible to think, how it's possible, how it's something strange possible, because in general you can think that it should be printed without empty lines. Okay, in this case, our result doesn't have in second part and in last part in the last task, our result doesn't have end line. As you can see, it's taken in this line. We don't have after this line. We don't have empty line because our result in second case it's only okay without new line character. Okay, let's forward. Let's go forward. In general, there is almost the same situation, with exception that, how to say, I would like to tell you that you can add some kind of control, flow control parameters. Flow control means you have possibility to control what will happen with your task, with your continuation task. Example, you can define that next the task will be executed only when everything will be correct, without an exception, without an errors, and similar situation. As you can see, one more information, our continuation has 20 versions. 20 versions. If you, during the programming, you probably saw that our Visual Studio, your Visual Studio gives you information, gives you some kind of help, some description to the methods. And as you can see, our methods, our continue with method has 20 version. 20 version means that 20 different 20 different group of parameters we are able to use. Or set parameters we are able to use. Example, third one, use function, which define continuation function, and cancellation token. Next one takes function and task continuation options, and similar things. Then you can imagine that you have a lot of possibility how you can configure your task execution, the continuation task execution. In our example, we have used task continuation options as one of parameter. From task continuation options, you can choose the proper for you. I won't explain you because I don't remember everything what's going on. I only explain you the situation in which everything went correct. If everything went correct, then we can continue. And I have an example. The example is the same which was presented in the previous slide, with the exception because I have added task continuation options. Continue only when everything went correct. It means that if the previous task was finished properly, we will continue our previous task with the next task. If something went wrong, our continuation won't be made. We will stop continuation. We will break. We will interrupt continuation. it's good to know about it, about this kind of possibility. You can test it, you can execute it. Probably on during the laboratories, I remember that probably we don't have an exercises with this element, but it's good to analyze. It's good to analyze what is possible, how you can configure some kind of objects. Okay, let's go. Let's go. Continue with continuation options we have explained. Next possibility. It's similar to the method when all, but the method is called continue when all. It's static method contained in the task factory, and it's possible to create how to say, second task with some code to execution in case some kind of execution in case when one moment. Okay, let's come back. Let's come back to our presentation. Again, we talk about when all method. When all creates a task which holds previous task, more task, and when each previous task was finished, our new task made with when all was ready to do with something with the results. In this case, we have continue when all method, which allow us to define a continuation logic. Continuation logic. It means if added tasks added to our continue when all method task finished, we will execute next code which is defined as a next parameter. As you can see in this case, the beginning of our method is well known, I think, because we have defined 3 tasks with 3 different methods. Our task do something. It executed print numbers. Task execute print numbers method. And next, we are using in our code continue when all. Our first parameter of continue when all is a table of task, which is created here. This is a definition of creation of new instance of our table with initialization on place. It's possible. You could define it line before example and save it in the variable, but in this case we are creating in this line on the place the table of task with initialization. In initialization we have put 3 previous created task. And as a second parameter, we can add a method. A delegate in general. A delegate. In this case, we have used the lambda syntax to define some kind of logic which should be executed after when the previous tasks are finished. When the added tasks are finished, our logic will be executed. As you can see, our logic, we should put the result from the previous task to our logic. As you remember from the when all method, you should remember that the returned value contains a table of tasks in this case, a table of tasks in this case, which means that we can catch the result from the tasks added to our continuum method and do something with these results. In this case, we printed the results. We have printed the results. One strange syntax here tell us that the result contained in values variable in the cell number 0 with index 0 in the first cell is converted to the task string. We of course know that the values contains task with generic type string because our task here were created in this manner. Yes, our task 1, our task 2, and task 3 has a type task of string, but values holds an object, its type of object to make the functionality more general than you are able to put different type of task, not only one type, but you can put different type of task. And as you can think, as you can see, we can do something as the continuation from our previous task. When tasks are finished, we will execute next code. In our case, we have defined code which prints something, the numbers, the line of numbers, the lines of numbers gathered from the print numbers. In general, these numbers are gathered from print numbers methods on the screen, and our code, our method returns okay text, which is passed to the task. We could example print it. Oh, it's printed, and I can say that it's printed, but it isn't showed on the screen because on the listing, because the place was finished. Then I didn't add it, but probably in the next slide is added somewhere. No, it isn't. Well, it is here, but I don't know if it's the same. It's the same situation. Probably not. Because next slide show us how we can use continue and any method. I remind you that when any method will return us only one fastest task. Then, if we would like to run more than one task, but continue execution with the fastest one, we can use continue when any method taken from task factory. And example again. In the first part, I won't explain it because I told it as many times as I can't calculate how many times I explained it. Then next part, we have prepared tasks which are run in different methods. You remember that we have many methods which can be used to produce new task. And next line catches free our task. Our next line catches in the continue when any method catches our free task in the table and take it as a parameter. This table is taken as a parameter. Continue when any is waiting when fastest task is finished. When the fastest task is finished, this task is passed to the values variable. In this case, values you can use different name because it's defined by a lambda syntax. Or example, you can use method with a name. It's important only that this method should input parameter, object parameter. And we have easy logic. We have printed the result from the fastest task. Nothing more in this case, or maybe one more. And the return print, we have printed the result from the fastest task and the returns OK string. OK string we have returned, and as you can see, on the screen, on the console, we have printed the shortest one, because I remind you that I'm come back, that we have some kind of delay, which means that the fastest process will be the shortest one. It's all because there are similar processes, but the number of iteration is changed. Then the fastest should be with the lowest parameter. Okay. It was the last slide from this presentation. I have one more presentation, as I told you, one more translated, and more more presentation which are waiting for translation. But now let's come back to my folder. Okay, found it. Found it. Very good. Okay, let's make a short break. I have to find something to drink because my throat tell me that I have to drink something. 5 minutes or 4 minutes or 6, something about this.
It's all right, sir.
You can go and drink something too.
and come back. Check how much time we have. Something about 20 minutes. Okay. Okay. Probably you know that the application contains bugs, contains strange situation, contains something which isn't expected, some kind of code which isn't expected. In general, bugs should be resolved. If you find it, you should resolve it, but sometimes you can expect that in your application can happen situation in which you aren't able to resolve it. You can expect that it can happen, but you aren't able to resolve this situation. Example, you would like to connect to the server and server is turned off. Your application tried to connect, but the server doesn't exist. What you can do? In general, you as a programmer aren't able to resolve this situation. Someone should turn on the server, but of course, application shouldn't closed without the information. Shouldn't closed in its own without any information to the user or without any saved information or something like this. Application should be prepared to control this kind of situation. Application should has written code which will prevent what, or which will do something in the case when unexpected situation will happen in your code. This kind of unexpected situation are called exceptions. Someone very smart decide to give the name for this situation, not bugs, but exceptions. It's very good because it sounds better than exceptions sounds better than bugs in your code. Yes, but of course, as I told, if something unexpected happened, it not always means that you made a mistake in your code. Sometimes it can be sometimes situations can happen, like as I told you, like the situation in which the server is turned off, or example, you are using a data or application is using the data which are gathered from external source, and external source returns you strange data, example nulls, returns you nulls. What you can do with this? Your application should have some code. One moment. Emergency. Oh, emergency. I forgot this word. Has emergency code which will do what is important. Example, inform user closed before the close application. This code will close management resources which were opened earlier. Example, you are trying to read data from the database, from the database server, and application is trying to save it in the file on the disk. First, you have to open the file on the disk. Next, you are trying to connect to the server, and server isn't present. In normal situation, without catching exception, application will stop working. The file is opened. The system has trouble with organization, with management of this situation. But in proper application, you should put an exception catching in case when server isn't able. You should close the file and inform user that your application can't connect. I'm sorry. Application can't connect to the server, and close it after clearing the situation, environment, and similar things. Okay, then let's start from the beginning. Let's start from the beginning of exceptions, because I have to explain you some, in general, important information, because you will probably we will have to use it. We will have to use it somewhere in our code. Okay, the base exception is the class in general. It's the class, like your class which you are produce in your application, or existing classes. There is a class which holds some kind of properties, as you can see here, and some constructors, as you can see here. As you can see, constructor, there are 4 constructors in the basic exception, but one constructor isn't accessible from external. It's accessible only from classes which inherits from exception. And you can use one of these, you can use in your code one of presented methods, because you can create your own instance of an exception. Sometimes it's useful. Sometimes it's useful. Example, if you would like to test something. I remember in the previous slide. That I showed you an example when something doesn't work correctly, and it was made by throwing new instance of exception class. Then you can remember that you should remember that there exists an exception class which represents the strange situation in your code, or which can represent this kind of situation. Okay, let's go forward. There is a base exception, we can say, because in the system exists more type of exception which inherits from the exception. Of course, they inherits from the base exception. On the right side, we have an example: file not found exception. It means that somewhere in the system exists class which inherits from exception and has own name, file not found exception. It's very useful and very good, because different type of exceptions can be thrown in different situations. As in this example, system didn't throw the exception. System throw file not found exception. you can catch the special kind of exception. Example, you are expect that file can that there can be situation where file doesn't exist. Then you can control it if it's this kind of situation, file doesn't exist, or maybe something different happened. Yes, in case when file not found exception, when different type of exception is thrown or was thrown. Okay, you can see that could not find file D. The ABC takes that, yes, because in this example I added code which tried to open file on disk D. File ABC takes that. This file doesn't exist, then you have thrown an exception. Yes, and it means that there is a system exception, and more exceptions, more specialized exceptions, more exception for special situation. There is one example, special situation, file not found exception. But more, you can create your own exceptions. You can create your own exceptions. In this case, we have the easiest possible version, custom exception, our class custom exception, which inherits from exception class, from the main class exception. And if you would like, you can make more complex version in which you can use default or different type of constructors. As you can see, there is default exception contains 4 constructors. You can do the same in case when you example have, if you don't have a message, or if you have a message, and another exception which can be included inside your exception, and similar things, because sometimes it can be situation in which your exception is thrown because second exception was thrown or previous exception was thrown. Then you have to have possibility to join exceptions, to carry exception with the stack. Okay, one more information, or more informations about exception class. As I show you, exception class has some properties. Properties means places when the information about exception can be held. And the properties are described here. The most important, I think, is message, which tell us something. In the previous slide, the message was here. We have exception, file not found exception. Okay, but what's happened in details? Details are contained in the message property. In the message property, we have information could not find the file abc.txt. It's useful because you can know, you are able to repair it because you know what's happened. Not only that file doesn't exist, you know which file doesn't exist. It's a message charge off to hold this kind of information. Inner exceptions are very useful too, because sometimes, especially from some subsystems, the inner exception contains, for example, previous or more detailed exception. It's good to know that inner exception can hold additional important data. Next one, source, which tells you where in which library, on which exe file the the exception was thrown. It's very important if your application has more than one file. The short, small application in general can contains one file, but the biggest one can and should contains more file, more libraries, more DLLs, and information about the source of exception can be crucial. Because it's easier to find the place where exception was thrown. Next one, stack trace. Stack trace tells you the path, what method was called by which method from the beginning to the end. From the beginning of an application, from the main method, we can say main method, to the place, to the method in which the exception was thrown. It's very useful. It's very useful because it helps you to find. It helps you to find a place where the code doesn't work correctly. Okay, let's go forward, and we have some kind of example how we can use an exception to control flow of our application. I will try to explain very fast what's going on. We have created, something like a game. Yes, we can say something, application, some similar to the game. In our game, we have warriors. Our warriors can fight. Okay, and to proper inform different part of code that our warrior doesn't have enough energy, we of course could return some information, or we can throw an exception. Environment on some kind of control system tries to put our warrior to fight, but we have to tell everyone that something doesn't work correctly, that our warrior doesn't have an energy. It's a strange situation. It shouldn't happen in our system. Then we can define our own exception. It's nothing more than class which inherits from exception class. Then somewhere in the code we can write keyword throw and put new instance of our exception. With example message. With a message, if we have created additional constructors, then we can add more information. To our exception. It works in the same manner like in the previous example with a file. In this case, we are trying to open file. File doesn't exist. Exception is thrown. In our code, some kind of code tries to put our warrior to fight, but the level is too low. Then our code throws exception, no energy exception. It's similar situation, but of course in different case. And how you can use it, how you can manage this kind of situation, we will talk in the next week. We won't have laboratories in the Monday. Yes, probably in the Monday. Thank you. See you later. Later means in next Friday.
Thank you very much, sir. See you next week, Friday.
Thank you. Bye.
Would you mark my attendance, sir?
Who you are?
Denzel.
Oh, Mr. Denzel. Okay, one moment. I have to find the list. The list and more. I have to check, I have to make notes where we finished our presentation. We have finished our presentation on slide, or the next page will be 5 and presentation number 5. It's important because, as I told you, I have more than one group with the same presentation that it's difficult to remember everything. Okay, Denzel Nyoka.
Yes.
I found you on my list. I mark your attendance.
Okay, thank you, sir.
Thank you. Thank you.